Greetings, this is Rick Powers coming to you from my home office for Basic Statistics. Introduction to Learning Plan 3. So now that we've been doing this thing for a while, there are a lot of concepts that kind of come together during this learning plan to, if you want to say, the main goals of statistics. As you may recall, the main goal of statistics is to know what to expect, to be able to use data in order to make data-driven decisions, and specifically to use the ideas of probability to figure out how likely certain things are to happen and how unlikely they might be. And that's kind of the foundation, and we're going to build on that. Now, in order to make that happen, the first topic of this learning plan is to talk about the bell-shaped curve, specifically what's called the normal curve, mathematical construction that allows us to evaluate a lot of different situations which have similar shapes in the distribution of the data. We know numbers are always changing, and if we see a pattern that they are changing in a specific way, then that can help us. And turns out it becomes very important for us, not too far down the road, because once we understand the concept of the normal curve or the bell-shaped curve, then what's going to happen is we move into the topic of sample statistics. Almost all statistics that we work with is a situation where we're taking a small group out of a larger group, and we're trying to do what's called the process of statistics. And that is to use the smaller group in order to understand the larger group. So for instance, if I say, I want to know if a certain chemical is harmful to for human consumption, then I would say, well, maybe I'll do an animal study and see if I can use an animal to do that instead of just giving it to people. But I'm going to not give it to every animal that exists, right? I'm going to choose a small group of animals, give them this chemical, and then see what happens. And so then the sample is going to lead me to understand something about how it would affect the biology of the kinds of beings that process their food in a certain way. And so then hopefully that would extrapolate onto human beings. And certainly if we have something like, if I want to create a movie that's going to be popular, and I show it to a group of 100 people and they all say, hey, this stinks because of X, Y, or Z, then it's like, why would I want to send it out to millions of people if these few hundred people seeing the movie see there's significantly bad things, that there's something wrong with it, right? So we use the small group, and then we move to the larger group to understand it. Well, as it turns out, there are some specific situations when a sample, because samples have a certain kind of behavior, that they are going to produce bell-shaped data when we have a lot of different samples, because each sample will be different. But if we compare samples to each other, then mathematically, perhaps we can find that these samples give us a bell-shaped distribution. So then we can understand something about what's going on. Then, okay, we talk about the bell-shaped curve, the normal curve, we talk about sample statistics. Then we deal with one of the biggest concepts in statistics, the idea of the confidence interval. And I allude to this, I believe, in the material when we'll go through it, is that confidence intervals are seen as like one of the major ways in which we can understand statistics. So that when you say, how do I know what's going to happen in a situation? How do I know that a particular treatment would reduce blood pressure for people who struggle with that, for example? Well, I will see that it happens in the small group, in the sample. But then to be able to understand that, since samples have variation from one sample to the next, then I can use my mathematical ability here to say, I know I have a specific result from a sample, but then I can use the understanding mathematically to say, in the population, I will look to predict that it would be a possibility of being either this low number or this high number. So I'll have an interval between which I would say the population number will actually be between this and that. So a confidence interval is a way to use a sample in order to find an interval for a population measurement. So then we can say something like, I know that this might not work for everybody, this particular treatment that I have, but I believe that if I treat the population as a whole, I'm going to see things change, and I'm going to see it change from this number to this number. So it will be a reasonable thing to do because I see that it's going to make a change, a meaningful and significant change. Because it changed the sample, then I can generalize it into an interval estimate of the result in the population. So when we put all these three things together, the bell-shaped curve, understanding how samples work, and then to apply that knowledge to understand the results we might get from a population, then we're completing the process in a very important sense. We're actually getting information that we can use in order to make some decisions about things. Now, once we make that happen, then we have a lot of different ways in which we can apply the confidence interval. And then later on, we'll talk about a different method, which is based more in statistical tradition. But the idea of what do we want to do? It's almost like we're getting from the foundational topics we've talked about, just what probability is and so on. And we're going to get to a place where we can say, this is what we want. This is what we want to find using statistics. All right, so I hope that you can learn something about how statistics works as we journey through this. And best wishes for learning plan number 3.